So at this point, you guys probably have a pretty good idea of how to draw molecules, how to make sure that you can identify the polarity. And so then right now, I'd like to emphasize how you can use that polarity to determine the intermolecular forces that are going to hold a whole group of those molecules together as either a liquid or a solid, because they're going to have to stick together somehow. And the way they stick is through the polarity of those molecules. So as you've learned before, the three different types are hydrogen, dipole, and dispersion, and I'll show you one of each of those types so that you can see the differences in how those would work. I'll try to skip ahead a little bit on the first part of this, since we've done so much of that already, and just go to the part where you can know the intermolecular force that is holding the compound together. So before we get started, I'd like to write out how you know whether you're going to be using a hydrogen or a dipole or a dispersion force to stick that molecule together. And they exist on a continuum where hydrogen is going to be used for a polar molecule, as is dipole. And then a dispersion force is going to be used whenever you have a nonpolar molecule, because the polar molecule uses some kind of permanent attraction, and the dispersion force uses some sort of temporary attraction. And those attractions are always going to be that negative positive polarity, that negative and positive charge. So, for instance, well, let's look at oxygen first. Oxygen you draw by writing out the two oxygens, putting its valence electrons. You have two of them. Each of the oxygens have 6 valence electrons, and that gets you a total of 12 electrons. Well, now that's 6 pairs, and so we can put the 6 pairs around the oxygens like so, and then redraw that oxygen as a whole molecule. So it's linear, it has a bond angle of 180, and that's going to be a little bit more obvious whenever you have more complicated molecules. But so now comes to the important part. How do you stick this together? Well, you need to know what kind of polarity it has. So let's put the electronegativities in. Oxygen is 3.5, and so it has really no difference of electronegativities whenever you subtract those. And that means that both the bonds are nonpolar and the molecule is nonpolar as well, meaning that there are no electrons moving at all. They stay where they are, and it has an effective charge of 0. So there's nothing to stick one oxygen molecule to another oxygen molecule, and I can show you that by drawing that out. So if I have one diatomic oxygen and then another diatomic oxygen floating around here, there has to be something to stick these two together, and as it stands as a gas, normally there would be nothing to do that. So in order to condense it down into a liquid, there has to be some sort of external pressure added, or chilling effect, so that they slow down, so that they get very close together. And when they do that, there is this temporary attraction that forms. It's a temporary dipole. And so we could show the electrons shifting temporarily and showing like a little negative and a little positive force. Maybe this becomes a little bit of a negative, this becomes a little bit of a positive. But remember, this is not a permanent thing. This is only temporary because there is pressure and low temperature put on those oxygen molecules. And so after that's occurred, well, now you can see a little bit of a temporary attraction, and that is the dispersion force. So the ultimate answer is, for any kind of nonpolar molecule, You draw the molecule, draw a second molecule, show how those two molecules are going to be connected to each other, and label that with the force that holds them together. In the case of a nonpolar molecule, that is always going to be a dispersion force.